Luis receives a gift card worth $25 to an online retailer that sells digital music and games. Each song costs 89 cents, and each game costs $1.99. He wants to buy at least 15 items with this card. And then they want us to set up a system of inequalities that represents the scenario, and then identify the range of possible purchases using a graph. So let's see if we can do this. So he's going to buy some amount of games and some amount of music. So let's make those our two variables. So let's let x equal the number of music, or the amount of music. And let's let y equal the amount of games, or the number of game units, or whatever you want to call it, number of games. So we have the first constraint here, that the gift card is worth $25. So I'll underline the gift card is worth $25. So the total amount he spends on games and music combined can be no more than $25. So how much is he going to spend on music? Well, each song costs 89 cents. So he's going to spend 89 cents times the number of songs he buys on music, plus how much he's going to spend on games. Well, each game is $1.99, so he's going to spend $1.99 times the number of games he buys, and that has to be less than or equal to 25. Less than or equal to 25. So that's our first constraint. And then the second constraint is that he wants to buy at least 15 items with his card. So the number of songs plus the number of games has to be at least 15. So x plus y has to be greater than or equal to 15. And so just like that, we have our two constraints. We've set up the system of inequalities that represents the scenario. Now we need to identify the range of possible purchases using a graph. And this is a pretty straightforward graph to draw, this one down here. This one is a little less straightforward because it doesn't have nice round numbers. I mean, we could round it off to say this is 1x plus 2y. But instead of doing that, let's just take out a graphing calculator and graph it on that. And actually, before I graph it, let me put it in y equals mx plus b form, or slope-intercept form. So the second one right here, if we subtract x from both sides, we get y is greater than or equal to negative x plus 15. So that's the second equation. This first equation, if we subtract 0.89x from both sides, we get 199y is equal to negative 0.89x plus 25, and sorry, that should be less than or equal to, not equal to. This is an inequality. So negative 0.89x plus 25, and then divide both sides by 199. So you divide both sides by 199 by 199. Everything is divided by 199. And we get y is less than or equal to, well, the calculator will actually be useful for this. We have negative 0.89 divided by 199 is equal to negative 0.447, I think is pretty good. Negative 0.447. Negative 0.447x plus 25 divided by 1.99. So 25 divided by 1.99 is equal to 12.56. Let's just go with that. Plus 12.56. So that blue constraint, that we can't spend more than $25, when we put it in slope-intercept, it turns into this inequality. And the second constraint, that he wants to buy at least 15 items, turns into this inequality. So let's graph the two inequalities. Or let's graph the lines and then think about the region of overlap. So if I have my calculator out, I should have it in a place where I could have looked at both graphs. So let me click on graph. Y equals, so this first one is negative x plus 15. And then press enter. The second equation is negative 0.447x plus 12.56. And now we're ready to graph them. So second, and then we are ready to graph them. And let's see what happens. OK, so it looks like we're a little bit out of the range of where you would expect to be hanging out here. So let me change the range. Let me go into the positive range, which makes sense because he can only buy positive units of things to begin with. So let's make the minimum x value here 0. Let's make the maximum x value here So let's make the maximum x value here 20. Let's make the x scale. Let's just totally make that 1. The minimum y value is 0. He can't buy negative number of games. Let's make y max 20 and y scale is 1. And now let's graph it. Now let's graph it. There you go. So we're sitting in the positive quadrant. So the first graph right here, this one on the top right here, this is the orange graph. This is y is greater than or equal to negative x plus 15. And actually, even better, so I can color it in, I'm going to pause the video a real second and then try to copy and paste this image so I can color it in. Hold on one second. So I've pasted it in here so I can actually draw on it. So this first graph here, y is greater than or equal to negative x plus 15. This is this top line because it has a higher y-intercept than this other guy. This guy's 12.6. So let me color it in that same color. So it is that line right there. Right there. And you can see it has a slope of negative 1. So it's that line. And we want to be greater than or equal to that line. So we want all of the values above that line, including that line. We could also be equal to that line. So it's everything above that line. Now this blue line is the other one. It's this one right here. It's that one right over there. And we have to be less than or equal to it. And we can see it has a slope less than 1. It's less steep, or a slope less negative than 1. It's actually a larger number, but it's a less downward sloping, and that's because it's negative 0.44 as opposed to negative 1. It has a lower y-intercept. And we want all the values below it or equal to that line. So all of these values over here. Now, the area that overlaps between these two constraints, I'll do it in this yellow color, is below the blue line, including the blue line, and above the red line, including the red line. So it's this area right here. It is that area right there. So any combination of games and music that are in that area will meet both of his constraints. And one thing you might want to consider, since you can't buy half a game or half a song, it would only be kind of the integer coordinates in this region that would satisfy his constraints. So however many games, however many songs this is and music is, this would satisfy his constraints.